For most people, the idea of getting around on a flying car seems possible only in the distant future. But in China, that reality may not be so far away.
The future many people only saw in movies may have just arrived as China reportedly launched the world's first flying car. The announcement is turning heads around the world, and even the United States understands how this bold move changes the global tech race overnight. But how real is this invention? Join us as we explore the future of transportation. China's new era, breakthrough. China spent many years investing in new transportation technology, and one of the biggest results of that effort appeared in the form of electric flying vehicles designed for short travel in cities. These aircraft are often called flying cars, but most of them are actually electric aircraft built for low-altitude travel above cities and highways. The goal behind this technology was to reduce traffic congestion, shorten travel time, and open a new type of transportation system that could operate in the air just above urban areas. One of the biggest breakthroughs came from a Chinese company called EHang. The company developed an aircraft named the EH216S, a small electric aircraft designed to carry 2 passengers. The aircraft uses electric motors and multiple propellers that allow it to rise straight up from the ground before flying forward. This type of aircraft is called an electric vertical takeoff and landing aircraft, also known as eVTOL. Unlike traditional airplanes that require long runways, these aircraft can lift straight up from small landing areas, making them suitable for crowded cities. The aircraft achieved a major milestone when Chinese aviation regulators approved it for operation. The Civil Aviation Administration of China granted the aircraft a type certificate after a long testing process that lasted more than 1,000 days. During this certification process, the aircraft had to pass hundreds of technical tests and safety checks. These tests examined flight systems, aircraft structure, battery systems, navigation systems, and emergency procedures. After the certification process was completed, the aircraft became the first passenger-carrying autonomous eVTOL aircraft in the world to receive this type of approval. The EH216S aircraft itself has a unique design that separates it from traditional airplanes and helicopters. The aircraft uses 8 arms that extend outward from the body of the vehicle. Each arm holds 2 propellers, creating a total of 16 propellers that help lift the aircraft into the air. The electric motors that power these propellers allow the aircraft to take off vertically and hover steadily before moving forward. The aircraft stands about 1.9 meters tall. Its width is about 5.7 meters when its arms are extended, and it has a maximum takeoff weight of 620 kilograms. The aircraft also operates using an automated flight system. Instead of a traditional pilot controlling the aircraft during the flight, the system relies on advanced flight computers and navigation software. Passengers select the destination, and the system controls takeoff, navigation, and landing. This approach reduces the complexity of flying and allows the aircraft to operate in fleets that can be managed by centralized systems on the ground. This concept is similar to automated drone technology, but scaled up to carry human passengers safely through the air. Before receiving approval, the aircraft completed a series of flight tests. These test flights allowed engineers to measure the performance of batteries, motors, sensors, and navigation systems under many different conditions. Test flights were conducted in multiple locations to observe how the aircraft behaved in different weather patterns and environments. These flights also helped engineers refine flight control systems that maintain stability during vertical takeoff and landing. More than 40,000 flights were conducted during testing and certification programs. After certification, the aircraft moved closer to commercial use. Production facilities were prepared so the aircraft could be built in larger numbers. Manufacturing procedures were established to ensure that every aircraft leaving the production line met the same safety and performance standards as the tested models. Quality control systems were also developed to monitor parts suppliers, assembly procedures, and flight tests before delivery to operators. These steps help prepare the aircraft for regular use in transportation services. The aircraft is expected to serve several roles when deployed widely. One of the first uses is short sightseeing flights over cities and tourist locations. These flights allow passengers to experience low-altitude travel, while regulators continue to expand operational rules. Another expected use is urban transportation between major locations, such as airports, business districts, and transport hubs. Emergency services and medical transport are also possible uses for these aircraft. due to their ability to travel quickly above traffic congestion. This technological breakthrough represents more than just a new type of vehicle. It represents the early stage of a completely new transportation network operating in low-altitude airspace above cities. The certification of China's first passenger eVTOL aircraft therefore marked the beginning of a new phase. This achievement positioned China as one of the leading countries in the race to build practical flying vehicles that could transform how people move through cities. How the flying cars actually work. Flying cars developed in China rely on a combination of electric propulsion, lightweight aircraft design, and automated navigation systems. The technology behind these aircraft is called electric vertical takeoff and landing, commonly known as eVTOL. The concept combines ideas from helicopters, drones, and electric vehicles. Like helicopters, the aircraft can lift straight up into the air without needing forward speed. Like drones, they use multiple small propellers instead of a single large rotor. Like electric cars, they use rechargeable batteries and electric motors rather than fuel-burning engines. The propulsion system is one of the most important components of these vehicles. Electric motors spin propellers that push air downward, creating lift that raises the aircraft into the sky. Because electric motors can respond quickly to computer commands, they allow the aircraft to maintain stable flight even during vertical takeoff or landing. Multiple propellers also increase safety because the aircraft can maintain balance even if one motor fails. The distributed propulsion system spreads lift across the entire structure of the aircraft. Battery technology also plays a central role in the design of flying cars. These aircraft use high-capacity lithium batteries that store enough energy to power the electric motors throughout the flight. Engineers design battery systems that balance energy storage, weight, and cooling systems. Because batteries add weight, aircraft designers must carefully manage how much energy the aircraft carries while maintaining safe flight performance. This balance determines the maximum distance the aircraft can travel and the amount of payload it can carry. In many Chinese flying car designs, the aircraft is capable of flying at speeds of around 130 kilometers per hour. These speeds allow the aircraft to travel between locations much faster than cars driving through crowded city traffic. For example, a trip that might require 40 minutes on busy roads could take only 10 or 15 minutes through low-altitude air travel. This speed advantage is one of the main reasons companies are investing heavily in urban air mobility systems. Flight control systems are another major element of flying car technology. These systems rely on advanced software that constantly monitors the position and movement of the aircraft. Sensors measure altitude, speed, orientation, and location during flight. The computer processes this information many times each second and adjusts the power of each motor to maintain stable flight. This automated control system makes it possible for the aircraft to fly safely even in complex environments such as city skylines filled with tall buildings. Navigation systems also guide the aircraft along predetermined routes. These systems combine satellite navigation, onboard sensors, and communication links with ground control networks. Digital flight paths can be programmed so aircraft travel along safe corridors in the sky. Ground control systems can monitor multiple aircraft at the same time and coordinate their routes to prevent conflicts or congestion. This network approach allows many aircraft to operate simultaneously without interfering with each other. Another interesting design concept being developed in China involves hybrid vehicles that combine a road vehicle and a detachable aircraft. One example is a modular flying vehicle that carries a small aircraft inside the rear section of a ground vehicle. When the driver reaches a suitable launch area, the aircraft portion can detach and take flight. After landing, it can reconnect with the ground vehicle for road travel. This approach allows users to travel on roads when necessary and switch to air travel when conditions allow. The interior of these aircraft is designed for short trips rather than long journeys. Most flying cars are built to carry 2 passengers seated side by side. The cabin usually includes large windows, so passengers can observe their surroundings during flight. Control panels inside the cabin allow passengers to select destinations and monitor flight information. Because the aircraft uses automated flight systems, the passenger experience focuses more on navigation and comfort rather than manual control. Safety remains a central concern in the development of flying cars. Engineers design multiple layers of redundancy into flight systems to prevent accidents. Sensors monitor every part of the aircraft during flight. If a malfunction occurs, the system can adjust motor speeds or change flight paths to maintain stability. Emergency landing procedures are also programmed into the flight's software to ensure that the aircraft can land safely if unusual conditions appear. As these technologies improve, the performance of flying vehicles continues to increase. China's investment in these technologies has helped accelerate progress in the global urban air mobility sector. Aviation companies, research laboratories, and government agencies are cooperating to build the infrastructure needed for low-altitude transportation networks. The result is a rapidly evolving industry that aims to transform how people move across cities. Electric flying vehicles could become a new layer of transportation above existing road networks. By using airspace, these aircraft could reduce traffic congestion and shorten travel times across large metropolitan areas. Build components. Modern flying vehicles developed in China are designed with advanced aviation components and futuristic passenger features. The main body of the aircraft is built using lightweight materials such as carbon fiber and aluminum alloy. These materials are extremely strong while remaining light enough for efficient flight. The structure forms a compact cabin in the center of the vehicle where passengers sit. Engineers designed the body to keep the center of gravity low, so the aircraft stays stable in the air. The outer frame also protects key flight systems such as batteries, computers, and navigation equipment that are placed within the fuselage. The cabin design inside these flying vehicles focuses on passenger comfort and simplicity. Most passenger models are designed to carry two people seated side by side. The seats are built with ergonomic designs inspired by high-performance automotive seating. Large panoramic windows surround the cabin, so passengers can see the landscape below during the flight. These windows provide a nearly 360-degree view, turning the journey into a sightseeing experience even during short trips. Another striking feature of many flying cars is the door design. Instead of traditional side doors like those on cars, many aircraft use gull-wing doors that open upward. This design allows passengers to enter and exit easily, even when the aircraft is parked in tight landing areas. The upward opening motion also adds to the futuristic appearance of the vehicle, making the aircraft look more like a spacecraft than a normal transport machine. Inside the cabin, control interfaces are simplified, so passengers can easily interact with the aircraft's systems. Instead of complex cockpit instruments and control sticks, many designs include digital screens or tablets mounted in front of the seats. These displays show flight information such as speed, altitude, battery status, and navigation routes. Some aircraft models use two touchscreen panels that allow passengers to select destinations or view flight data. These interfaces make the experience feel similar to using a modern smartphone or tablet instead of operating the usual cockpit. The landing gear system is another important structural feature. Many flying cars use sled-style landing skids instead of traditional wheels. These skids allow the aircraft to land smoothly on flat surfaces such as rooftops or landing platforms. The design reduces mechanical complexity while making the aircraft easier to maintain. The skid system also spreads the landing force across a wider area, helping stabilize the vehicle during vertical landings. Lighting systems are integrated throughout the aircraft to support safe operation in different environments. Navigation lights and strobe lights are mounted on the exterior, so the aircraft remains visible to other aircraft and ground observers. These lights also help guide the aircraft during nighttime flights. Engineers include additional sensors and lighting systems that assist with safe landing during low visibility conditions. The aircraft also contains a large network of sensors and onboard computers that monitor the condition of every major component. These systems continuously check motor performance, battery health, and flight stability. If any irregular condition appears, built-in safety systems can activate backup components automatically. Many flying vehicles include redundant flight control systems, backup sensors, and multiple computing units to ensure reliability. These redundant components form an essential safety layer within the aircraft design. Communication systems are another key component integrated into the aircraft structure. Many flying vehicles include wireless connectivity that links aircrafts to ground control networks. Through the communication systems, operators can monitor aircraft position, performance data, and flight status in real time. This connectivity also allows fleet management systems to coordinate multiple aircraft operating within the same region. The communication equipment is carefully integrated into the aircraft's electronic architecture to ensure stable connections during flight. Exterior design also plays an important role in the aircraft's overall appearance and function. The shape of the body is carefully designed to reduce air resistance while protecting internal systems. Smooth curves and aerodynamic surfaces help air flow efficiently around the aircraft during flight. Engineers combine functional design with futuristic aesthetics, so the aircraft represents both advanced technology and modern transportation design. Some flying vehicles also include specialized compartments for luggage or equipment. Small cargo areas allow passengers to bring personal items during short flights. These compartments are integrated into the aircraft body without interfering with passenger space or flight systems. Even though these aircraft are relatively small, designers carefully considered interior space. Together, these components create a machine that looks different from any traditional vehicle, giving people a glimpse of what future transportation may look like as cities begin exploring travel above the streets. The industry around flying cars. China did not treat flying cars as a single experimental project. The country began building an entire industry designed around what planners call the low-altitude economy. This concept focuses on transportation and services that operate in airspace below about 1,000 meters above the ground. Within this layer of airspace, new aircraft such as drones, air taxis, and flying cars can operate without interfering with commercial aviation. The development of this industry involves aircraft manufacturing, navigation systems, landing infrastructure, battery technology, and digital traffic control networks. Government planners recognized early that urban traffic congestion was becoming a major problem in large Chinese cities. Roads in major urban centers such as Shenzhen, Guangzhou, and Shanghai became extremely crowded as millions of vehicles filled highways and city streets. Engineers and technology companies began exploring whether electric aircraft could create an additional transportation route above existing road networks. The idea was to create a new system where short trips between important locations could happen through the air rather than on the ground. Chinese companies quickly began developing many different aircraft models to compete in this emerging industry. Some companies focused on small, autonomous aircraft designed for short sightseeing trips or city transportation. Other companies began designing larger aircraft that could carry more passengers across longer distances. Several designs even included cargo aircraft that could transport goods fast between logistics centers. The diversity of designs showed that the industry was evolving beyond experimental prototypes and into a full ecosystem of different vehicle types. One important company in this sector is Xpeng Aero HT. This company focuses on developing hybrid vehicles that join road transportation and air travel. The company created a modular flying vehicle, sometimes called a land aircraft carrier. The vehicle operates as a ground vehicle that carries a detachable aircraft module. When the driver reaches an appropriate launch location, the aircraft module separates and performs a short flight. The aircraft then lands at another location, where it reconnects with a ground vehicle for continued travel. This concept aims to combine the flexibility of road transportation with the speed of air travel. Another group of companies is working on larger passenger aircraft that function more like small electric airplanes. These vehicles are designed to carry several passengers and travel longer distances between cities. An example is a Lift Plus cruise aircraft capable of carrying 5 passengers with a range of around 250 kilometers. This design uses vertical propellers for takeoff and landing, while additional propellers provide forward flight once the aircraft reaches cruising altitude. Such aircraft represent the next stage of development beyond the smallest urban flying vehicles. The growth of this industry has also been supported by huge investment in research, development, and production. Factories dedicated to manufacturing these aircraft are also under construction. One large production facility in Guangzhou has been planned to manufacture thousands of flying vehicles each year. Large-scale manufacturing will allow companies to reduce production costs while improving reliability and quality control. The long-term goal is to produce flying vehicles in numbers similar to electric cars rather than traditional aircraft, which are normally built in small quantities. Market analysts estimate that China's low-altitude economy has already grown into a large emerging sector. The market value of this industry reached more than 500 billion yuan in 2023, Forecasts suggest the sector could exceed 1 trillion yuan within a few years as new aircraft services begin operating commercially. This rapid growth demonstrates how seriously the country is pursuing the development of aerial mobility systems. Infrastructure planning is another major part of the strategy. Engineers are designing landing platforms called vertiports that can be built on rooftops, transportation hubs, and open urban spaces. These vertiports will allow flying vehicles to land safely while passengers enter and exit the aircraft. Charging stations will also be installed at these locations, so electric aircraft can recharge between flights. These facilities are expected to become a new type of transportation hub, similar to bus stations or train terminals. Artificial intelligence and automated monitoring systems will coordinate routes and prevent aircraft from interfering with each other. China's long-term vision involves building entire transportation networks that operate both on the ground and in the air. Cars, trains, and buses will continue moving people through cities on roads and railways. At the same time, electric aircraft will provide fast connections between key locations above the city. These combined systems could transform how people travel through some of the world's largest metropolitan areas. The global technology race. The development of flying cars has become part of a broader global technology competition. Several countries are attempting to build the first practical systems for urban air mobility. The United States, Europe, and China all have companies working on electric aircraft designed for short travel routes. Engineers, technology companies, and aviation regulators work together to move this idea from research labs into real machines that work. However, the speed of development has varied depending on government policy, investment levels, and regulatory approval processes. China's aviation regulators moved relatively quickly to establish certification procedures for electric vertical takeoff aircraft. By creating clear guidelines for testing and safety verification, regulators allowed companies to move through the certification process faster than many competitors in other regions. This regulatory progress enabled Chinese companies to conduct extensive testing programs and begin preparing for operations, providing Chinese companies with a head start in the race to deploy commercial services. In the United States, many companies are also working on electric aircraft technology. Several American startups are designing aircraft intended for air taxi services between airports and city centers. These aircraft often use tilt-rotor designs or hybrid propulsion systems that combine vertical lift with efficient forward flight. American companies have attracted significant venture capital investment and have developed several advanced prototypes. However, certification rules for new aircraft types can take many years to complete. Aviation authorities must examine aircraft structures, propulsion systems, flight control software, and emergency safety procedures before allowing passenger flights. Because flying cars represent a completely new category of aircraft, regulators must design entirely new rules for how these vehicles will operate in shared airspace. Another factor influencing the competition is manufacturing capacity. China already has one of the world's largest electric vehicle manufacturing industries. The experience gained from building electric cars provides important advantages for electric aircraft development. Battery production, electric motor manufacturing, and lightweight composite materials are all technology shared between electric cars and flying vehicles. Companies can adapt existing supply chains to support the new aviation sector. Software development also plays a critical role in modern aircraft systems. Autonomous navigation, obstacle detection, and traffic coordination require advanced computing systems capable of processing large amounts of data during flight. Artificial intelligence algorithms help aircraft maintain stable flight while adjusting motor speeds and flight paths. Chinese technology companies have invested heavily in these types of digital systems. International interest in flying cars continues growing as cities around the world search for solutions to transportation congestion. Urban air mobility could eventually become a global industry, with many competing aircraft manufacturers and service providers. Countries that develop reliable aircraft early may gain significant advantages in exporting these technologies and establishing global standards for aerial transportation systems. What are your thoughts on the future of simplified air transport? Let us know your views in the comments. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.